return, for example, a bad request, and let's just return validation result to dictionary. This is going to serialize the validation errors as a dictionary that I can return to the client. Let's go ahead and test this out. I'll send a request with an empty name and a description that is more than 50 characters long. And if I send this request, you will see that we are getting back a 400 bad request, and the response contains our specific validation errors that we defined using the Fluent validation approach. However, this isn't a problem details response. So I started by returning a bad request. But what we can do instead is return a validation problem. And one of the arguments that I can pass in is a validation problem details instance. This accepts a dictionary of errors, which is what I can specify by calling to dictionary on the Fluent validation result. Let's start the application again and test out this implementation. I'll send the same request again to the API, and we are getting back a 400 bad request response. There is a title that one or more validation errors occurred, and the status code is 400. The specific errors are now part of an errors property, which is like an extension on the problem details object. However, the response is missing the type property and the trace identifier. Let me show you another approach for returning this type of response. We can inject a new service called the problem details factory, and if we encounter a validation problem, we can use the problem details factory to create a problem details instance. We have to pass in the HTTP context and the status code that we want to use, let's say 400 bad request. And once we have our problem details instance, we need to extend it with the errors dictionary. So I can say problem extensions add, specify the errors value, and pass in validation result to dictionary. And then we need to return this as a response of this endpoint. And for example, I can say return bad request and specify the problem instance. And if I send the same request again, you can see that now I'm getting back a proper problem details response because it's being created by the problem details factory, which is what's creating the problem details instances in general when we return failure results in ASP.NET Core. You can see that the type is properly set, we have bad request as the title, the status code is 400, the trace identifier is there, and so is the errors property that we specified as an extension. However, doing this manually is a bit cumbersome. I will show you one approach to standardize this in our next lesson by throwing an exception here instead of returning a validation result, and then writing the logic for generating a problem details response just in one place. Let's navigate to the create habit DTO, where I want to introduce a more complex validator. So I'm going to paste in the validator type, and I'm going to walk you through the implementation. Hopefully, this will illustrate that you can introduce some very interesting input validation rules using this library. So let's say I want to have some predefined values for the allowed units inside of the habits that I want to track. You may even pull these from some configuration values and even the database, because these validators also support dependency injection. When it comes to the validations themselves, I can chain as many validation rules as I want, and I can even provide custom validation messages by calling with message and providing the value that I want to return. The validations can be applied conditionally. For example, I only want to enforce the maximum length validation when the description is not null. Also, when it comes to something like an enum, I have an isInEnum validator that's going to check that the provided value is actually a valid enum. Now in .NET, you can cast any integer to an enum, and this is going to succeed even though it's not a valid enum type. I have a couple of more validations similar to this. For the end date, we only want to validate it if it's not null, and we want to check that the end date is not in the past. So this is how I can define that validation rule. When I want to apply a validation rule conditionally, I can wrap this using the when method. And for example, when the milestone is not null, I want to have a rule that the milestone target has to be greater than 0. If we need some custom validation rules, we can also extract them into a method that can be enclosed inside of the validator itself, or it can even call out to a helper service that's going to wrap the validation logic. And let's say in this example, I'm checking that the target unit is compatible with the specified habit type. Let's add support for calling this validator inside of the habits controller. I will navigate to the create habit endpoint, and I need to inject an iValidator for the create habit DTO. let's go ahead and call validator validate async, pass in the DTO instance, and I will get back a validation result. And if the validation result is valid, is not true, then I'm going to return bad request, and I'm just going to say validation result to dictionary. So let's observe what we get back from this endpoint when we run into some validation problems. Here is the request I want to send to the API. I want to create a habit with a bunch of invalid values. For example, the habit type is not valid, the frequency type is not valid. I can make a typo in the units so that this value isn't valid as well. The target milestone is a negative number and the end date is in the past. And if I send this request, we're going to get back a 400 bad request as expected, and the response contains the errors dictionary. You can see that for each type inside of my request, I have a respective error. So I specified an invalid habit type, I specified an invalid frequency period, the target unit isn't in the allowed units that I want to support, the end date has to be in the future, and so on. So this is how you can start introducing some more advanced and dynamic validation rules using the Fluent Validation Library. Now I'm going to close down the habits controller. In the create habit DTO, I'm going to extract the validator into its own file, and then let's close this down. And in the create tag DTO, I'm also going to extract the validator into its own file, and I will close down both of the files as well as the program file. I want to show you just one more thing when it comes to returning back a problem details response or some other types of validations like the conflict validation in this example. If I were to just return a conflict result, it will just include the string that I specified here in the response body. So what you can do instead is return a problem response or a problem result object, and you can specify some additional information by providing the specific values that will be translated on the problem details object. For example, I can set the detail property, and another one that is important is the status code. For this, I can use the status codes class and access the 409 conflict value, and this will return the same response back to my client, except as a problem details response. Let's go ahead and test this out. I'll send one request to create a new tag with the name of .NET. And if I send this request, you will see that this will succeed, and I get back a 201 created response, and my tag is successfully persisted inside of the database. Now, if I send the same request again, I'm going to trigger my validation rule, which makes sure that my tag names are unique, and I'm going to get back a 409 conflict response as before, except this time is going to be a problem details object. It's going to use the correct media type in the response as well, and you can see that the specific detail is present in the detail property. It says that the tag .NET already exists. So this is how you can return a problem details response to your API clients and also include some additional information. Now I also want to mention the trace identifier value because I think it's very useful. So I'm going to take this value here, which is the trace ID, and head over into the Aspire dashboard. If I take a look at the distributed traces, I see all of the traces inside of my system, but I can apply a filter. And in this filter, I can pick the trace ID and check that it contains the value that I got back inside of my problem details response. And once I apply this filter, now I can navigate to the specific distributed trace for the request that I sent to my API. And I can open up this request and observe some additional information. For example, here is the specific query that we send to the database to validate if a tag with this name already exists. So I want to show you one more thing and we're going to wrap up this lesson. Let's go to the program file. And for example, after adding the Fluent Validation Services, I will say builder services add problem details. This also accepts an action where I can configure the problem details options, and this has another action called the customize problem details. Here I can use the problem details context to configure how the problem details is constructed using the problem details factory. And for example, I can access the specific problem details instance, and let's say I want to always add some sort of extension value. I can use the try add method, specify the key for this value, and the response could be something like context. Let's grab the HTTP context and return the trace identifier. Now this value is slightly different than the trace ID that is specific for OpenTelemetry, which you saw in the previous example. The trace identifier available on the HTTP context is specific to to ASP.NET Core, but it can also be useful for observability and filtering out your structured logs. And with this, I'm going to conclude our lesson about implementing input validation in our REST API, but we did leave a few open questions, mainly about exception handling, which is what we are going to discuss in our upcoming lesson.